Hello everyone, it's me Amna and welcome to Amna's Learning Hub. I hope you all are fine and finding my videos helpful. Today I'm here with another video of organic chemistry. If you have seen the series of organic chemistry that I am uploading, so you must know that in previous lecture we discussed about the chemical reactions of alkanes and alkenes. So in alkanes I discussed about the combustion and substitution reaction, and I also gave you an assignment about that. Today we are going to study about chemical reactions of alkenes. In alkenes we are going to discuss two types of reaction. One is combustion reaction and other one is going to be addition reaction. So combustion reaction, if you remember the previous lecture, the products will be same, the reaction will be same. So in combustion reaction we have two types of reactions, two types of combustions. One is complete combustion and other is incomplete combustion. Incomplete combustion, the products are carbon dioxide and water, whereas in incomplete combustion the products are carbon dioxide, carbon monoxide and water. A small amount of carbon dioxide, more carbon monoxide and water. Right? In addition reaction, we are going to describe four types of reactions, four different addition reactions. Let's dive into the details of those addition reactions. So, the addition reactions of alkenes are first, we will discuss about addition of hydrogen, which is called hydrogenation. Next will be addition of halogen and then addition of water, and last is the polymerization. So now I am going to describe every one in detail with the chemical reactions, with the conditions of the reactions, with the reactants and the products, that how the reaction is going to happen, what is the chemistry behind these addition reactions of alkenes. Okay. First of all, you must have an idea that why alkenes give addition reaction. Why alkenes give addition reaction. Let's take a simplest alkene, which is ethene, CH2 double bond with CH2. If you've taken my previous lectures, you must know that, or if you're the student of chemistry, you must know that carbon always form four bonds. So in this case, carbon is forming two bonds with hydrogen and two bonds with other carbon. So four bonds are satisfied like this. So that means this one, in these double bonds, this one bond is the extra bond which can be break down and which can be converting into the, which is providing the space to add something into the compound. Because we know that it is compulsory for carbon to make single bond to be a saturated compound, but in this case when the compound is unsaturated, it has ability to break one bond out of two and then make a product, right? So let's have the diagram of the CH2, which should be like this: carbon making one bond with hydrogen, one bond with other hydrogen, then two bonds, then carbon making one bond with hydrogen and one bond with another hydrogen. We are adding hydrogen in it, right? First reaction, addition reaction, if you can recall, is hydrogenation. That means addition of hydrogen. So we are going to add hydrogen in ethene. So hydrogen is this. Hydrogen also exists in diatomic form, because we know that all the gases exist in diatomic form. So the reaction will take place in certain conditions, and the conditions are nickel as a catalyst and 200 degrees Celsius is the temperature. Conditions of the reactions are very, very important. So in hydrogenation, nickel as a catalyst, and 200 degrees Celsius is the condition that must be fulfilled. If the condition is not given, if the nickel is not present, the rate of the reaction will be very slow, because we know that if we don't use catalyst, the activation energy is very high and it takes a lot of time to be converting into the product. So other one is the temperature, which is also working in this way, that it will provide an lower activation energy. It will also act as a catalyst, and it also increases the rate of reaction. Okay, so now we know that this hydrogen will attach to this carbon, and this hydrogen will attach to this carbon, and this double bond will be broken down. So the new product which will be formed is carbon is making 3 bonds with hydrogen, and carbon is making 3 bonds with hydrogen and 1 bond with carbon. So double bond breaks, and both of the carbons got a space in which they accommodated new coming hydrogens, and the product will be from alkene to alkane. And this reaction is known as addition reaction, and this happens in the presence of nickel as a catalyst and at 200 degrees Celsius. I hope hydrogenation is clear to all of you. Let's move to halogenation. We all know that halogen means X2, which is fluorine, chlorine, bromine and iodine. We know that fluorine is highly electronegative and it provides a very fast reaction. That is why we use less fluorine in reactions. Because the reaction is very fast, it is very difficult for us to observe the reaction. Iodine is bigger in size, and electronegativity of iodine is low, and it provides a very slow reaction. So two conditions are left, two compounds are left, chlorine or bromine. So in this case, we are going to discuss about bromination, because I need to give you some information about a test as well, that what test occurs with this. Okay, so we know that we have an idea that bromine, Br, so that means it is reddish brown in color. So now we have CH2 double bond with CH2, another ethene, in which I am going to add bromine, which is aqueous. The whole solution is aqueous. Then when I add bromine, so bromine will be attached with both of the carbons. So Br2 means Br and Br. So one Br will be attached with this carbon and other Br will be attached with this carbon. So new product will be CH2 single bond with CH2, Br and Br. This process is called bromination. There are no certain conditions for bromination. It can occur at room temperature. So in bromination, what happens? Bromination is also the test of unsaturation. This is also the test for unsaturation. So how can we perform this test? We simply take any compound. We don't know whether the compound is saturated or unsaturated. We will simply take the compound in a beaker. Then we will add a few drops of bromine. That is liquid, a brownish liquid solution. We will simply add a few drops of bromine. If the solution will remains brown, that means the compound is unsaturated, and if solution becomes colorless, that means the compound is saturated. I hope till this point you are clear about two reactions. We studied about hydrogenation, we studied about halogenation. Halogenation means addition of halogen, and halogens are fluorine, chlorine, bromine and iodine. I gave you all the reasons of the reactions, and if the reaction is with chlorine, it is known as chlorination. If the reaction is with bromine, it will be known as bromination. Let's move towards the next reaction, which is with water molecule. Okay, so the reaction first was hydrogenation, that meant addition of hydrogen, then halogenation, and now this reaction is going to be hydration. Hydration means addition of water molecule. Simple. Addition, positive means addition of water molecule. So what happens in this reaction? Again, we will have any alkene. For example, ethene again, CH2 double bond with CH2. This is ethene. It is reacting with water. H2O is water, right? So we can also write it like this. So it is addition of water. So when we are going to add water, there are certain conditions for the reaction, and the conditions are 60 to 70 atm pressure, then 300 degrees Celsius temperature, and H3PO4, that is phosphoric 5 acid. Phosphoric acid. So if we are talking about the addition of water, that is the steam, because the temperature is very high, so the ethene is reacting with water molecule at 60 to 70 atm pressure, 300 degrees Celsius temperature, and H3PO4 as a catalyst. So the whole conditions are required for this reaction, and when we perform this reaction, the product will be alcohol. So it can also be the reaction of synthesis of alcohol, and it is also the reaction of addition in alkene. So the product will be this hydrogen is going to attach with this carbon, or this hydroxide is going to attach with this carbon, or it can be done vice versa. So the new product will be CH3 CH2OH, and this alcohol is ethanol. So basically this is also the reaction of conversion of ethene into ethanol. So in all of the organic reactions, when you are studying the reaction, you have to learn the conditions, because conditions are very, very important. If any of the conditions are not satisfied, reaction cannot be performed. So in this hydration, I'm repeating, we just took water, 300 degrees Celsius was the temperature, 60 to 70 atmosphere was pressure, and H3PO4 phosphoric 5 acid was a catalyst. Then the ethene will be converted into alcohol. Last but not the least, about the addition of alkene, we are going to discuss about the polymerization. Polymerization is a very extensive topic, so we will cover this topic again in polymerization chapter, in which I will explain you about different types of polymerization and different uses of polymerization. For now, you just have to understand what addition polymerization means. What addition means. So, polymerization. In polymerization, any alkene, I'm taking CH2 double bond with CH2, we have N molecules. N means we have a lot of molecules, we have large number of molecules, because polymer is composed of millions or billions or hundreds of molecules. When they combine together, then it forms a long chain, and that long chain will convert it into a whole giant compound. So this ethene will be converting into polyethane. Ethene has double bond. Ethene is converting into CH2, single bond with CH2, and I am drawing these bonds. That means the chain is going on from both of the sides. Carbon must have made 4 bonds now. So in this case, this carbon is making 2 bonds with hydrogen and 1 bond with other carbon, 3 bonds, and 4th one will be extrapolated to another chain from this side, and this carbon will elongate into the other side in the form of long chain. So it will have n molecules, and the word poly comes when we have many molecules. So the ethene which had double bond is converted into ethane which has single bond, but there are millions of molecules of ethane after formation, and this is called polyethane. This is a polymer. In the chapter polymerization, I will explain all the things in detail, but for now you just have to memorize that double bond will be converting into single bond and the long chain of the compound will be formed, and this is called as polyethane. I hope till now the concepts about addition reactions are all clear. Let's do a summary of the reactions. In the reactions which we studied in alkene, I am going to write the summary of all of the reactions. So if I talk about alkene, we have studied 5 types of reactions. First one was combustion. Then we had addition. Let's take addition here. This is addition. In addition, we had addition of hydrogen, we had addition of bromine, we had addition of water, and we had polymerization. In combustion, we provide heat. This delta sign means heat, and oxygen is always required for combustion, whether it's complete or incomplete, and the product will be carbon dioxide and water. Here I am writing the products of only the complete combustion. Then in hydrogen, we have CH2 double bond with CH2, which is converting into CH3, single bond with CH3. That means unsaturated compound is converting into a saturated compound, and the conditions of the reaction are, here we are adding a hydrogen H2, and the conditions are nickel as a catalyst and 200 degrees Celsius temperature. Then we do bromination. In bromination, again we have CH2 double bond with CH2, which will be converting into CH2Cl, CH2Br and CH2Br. Then we have again CH2 double bond with CH2, and it is converting into CH3, CH2 and OH, and conditions of the reaction are, here we have steam, that means water at high temperature, 60 to 70 atm pressure, 300 degrees Celsius temperature, and H3PO4 is the catalyst. And after that, in polymerization, we have CH2 double bond with CH2, which is ethene, which will be converting into polyethane, and which is CH2 single bond with CH2, and the chain is extrapolated with n number of molecules. N means it can be 100, it can be 500, it can be 1000, it can be million, and it can be any number. So this was the whole summary of today's lecture, in which we studied about the combustion of alkene, we studied about the addition reactions of alkene, different addition reactions, and the conditions are written here. I hope there must not be any problem in this chapter. If you have any problem in this chapter, you can ask me on Instagram, and you can comment down on my YouTube video so that I can address your issue. I hope chemistry is getting easy for you all. Still, if you want any change in my teaching methodology, and if you want something new in my teaching method, so tell me. I will welcome all of you to get good suggestions from you all. So take care of yourself. See you in the next video. Allah Hafiz.